As a cell grows, we know that its radius will increase, so will its volume, its surface area, as well as the mass of the cell. What we'd like to do is be able to relate the rates of change, since these things depend on one another. Let's first talk about the mass of the cell. The mass of the cell is given by the cell density multiplied by its volume. Cell density we'll assume to be constant, and we'll call that constant rho. And so the mass of the cell can also be written as rho times 4/3 pi r cubed. Let's relate the rate of change of the mass, which is dm dt, to the rate of change of the radius. All of these constants will simply appear in the derivative. The constant will be preserved. Now we must differentiate this quantity, and here's where the chain rule comes in. So the derivative will first be the derivative of r cubed with respect to r, and then multiplied by the r dt. Therefore, the rate at which the mass changes is going to be this constant 4/3 pi times the density multiplied by 3r squared, which comes from using the chain rule, multiplied by the r dt. So observe that if someone gives us information about how fast the mass is increasing, then we can infer how quickly the radius changes. We can calculate dr dt. Or similarly, if someone tells us what dr dt is, we can then deduce dm dt.